this is Anuj from Chemical Engineering Concepts, and guys, we will be continuing our series on solution thermodynamics, and this is our next lesson on which we are going to learn about the residual properties of a mixture, right? Residual properties of a component in a mixture, right? All these things will be known to us. In the previous video, we had a basic discussion on the partial properties, the partial molar properties, and so on, right? The Gibbs-Duhem equation, Gibbs theorem, right? And we will be continuing our discussion with these residual properties now, right? So guys, first of all, let's define what are residual properties. So these are basically the variations, okay? If our property in a non-ideal mixture is varying from the ideal mixture, okay, so this deviation is actually told by the residual properties. So guys, properties of a mixture at any given point, at any given temperature and pressure, right, subtract the properties of an ideal gas mixture at the same composition and at the same temperature and pressure is equal to the residual properties. So guys, आप देख सकते हैं यहाँ पर that residual properties actually बताते हैं कि हमारा this is for the non-ideal, right? This is for the non-ideal system, right? So non-ideality में ideal system से कितना deviate करता है हमारी properties, that is actually told by the residual properties of a mixture, right? M is actually for the real gases. It can be used for the real gas, ideal gas, or even liquid mixtures, right? Subtracting by the MIG, that is going to be always for the ideal gas mixture, and this subtraction is actually known as the residual property, right? There could be residual Gibbs free energy, residual enthalpy, residual entropy, and so on and so forth, right? Let's move further and see why do we actually need to define these residual properties. हमें क्यों जरूरत पड़ती है that we need to define these residual properties, right? So what is the need to define the residual properties now? Actually, these residual properties are really helpful in defining the properties of a substance, properties of a component when we are having the non-ideal systems, right? So guys, to understand it in a much simpler manner, let's suppose we have two things, okay? We have ethanol as an ideal substance and ethanol as a non-ideal substance, right? So when I'm talking about the ideal ethanol, what does that mean? So it will be having the negligible volume when I'm talking about ethanol in the ideal phase, ideal system, right? And the intermolecular forces will be very negligible when I'm talking about the ideal ethanol, right? But because both are to be considered simultaneously, तो guys हम इनको same temperature and pressure पर ही evaluate करते हैं, same temperature and pressure पे consider करते हैं, right? Now when I'm talking about the non-ideal ethanol, the volume is going to vary, the intermolecular forces are going to vary, okay? अगर temperature pressure same भी रख रहे हैं हम, even then these two properties, the volume and the intermolecular forces, are going to vary. तो उस वेरिएशन को गाइस हम कैसे अकाउंट करें टू डिफाइन द एक्चुअल प्रॉपर्टीज फॉर अ नॉन आइडियल सिस्टम, राइट? सो इसमें एक्चुअली हमारा रेजिडुअल प्रॉपर्टीज गाइस हेल्प करने वाला है, राइट? व्हाट इज गोइंग टू डू, ये हमारा नॉन आइडियल प्रॉपर्टी है, right? Non-ideal, any non-ideal thermodynamic property at constant temperature and pressure will be equal to what? अब यहाँ पर guys आता है that we will be first calculating the property at the ideal gas, जो कि already calculated होती है, right? Which actually this is coming from the ideal gas law, right? So this we know, we can calculate it using the ideal gas law, right? And there are some correlations which have been developed in the form of the residual properties, right? रेजिडुअल प्रॉपर्टीज के फॉर्म में कुछ कोरिलेशंस को डेवलप किया गया है, राइट? जिससे इजीली वी कैन फाइंड आउट द प्रॉपर्टी ऑफ द नॉन आइडियल सिस्टम बाय जस्ट एडिंग द सेम प्रॉपर्टी एट द आइडियल गैस. तो क्या करने वाले हैं गाइस, नॉन आइडियल प्रॉपर्टी निकालने के लिए उसी प्रॉपर्टी की स्टेट सेम टेम्परेचर एंड प्रेशर पे आइडियल गैस पे कितनी थी, उसमें वी आर गोइंग टू ऐड this correlation at the same temperature and pressure, राइट। तो इस कोरिलेशन में जो टर्म आने वाला है हमारे पास, दैट इज द रेजिडुअल प्रॉपर्टी एंड दैट वी आर गोइंग टू डिस्कस टुडे, राइट। तो आपने एप्लीकेशन जाना, व्हाट व्हाई इज देयर नीड टू डिफाइन दीज रेजिडुअल प्रॉपर्टीज, राइट। So correlations are actually developed in terms of the residual properties, right? Let's move further and look at the how we will be defining these residual properties for in terms for the Gibbs free energy and so on and so forth, right? So guys, this is the famous relationship that we know, that is dg is equal to rt dl and f, right? We defined it when we were defining the fugacity, right? Fugacity के time पे हमने इसको define किया था. Now let's integrate this equation going from the ideal case to the actual case, right? From the ideal case to the actual case, and look, you can see this simple integration that I am doing here, right? For the actual case there is no suffix, but for the ideal gas case we are assuming we have this Ig representation, right? And you know that for the ideal case the fugacity is going to be pressure, right? So you can see this ratio, we know this is the ratio of the fugacity coefficient, that is this phi, right? Let's move further and now let's see the residual property for a component in a mixture. Guys, this is an important thing, right? How we have to define the residual property for any species that is there in the mixture, right? So for that, let's define Gibbs free energy. Let's see this with an example of Gibbs free energy, right? So Gibbs free energy, guys, ith species के लिए अगर हम लिखना चाहते हैं for the ideal gas mixture, this is the way we write it, right? This is the partial Gibbs free energy for ith species in the ideal gas mixture, right? This will be equal to the actual property, right? The ideal gas property of the ith component, right? For the pure component basically, plus this change. Okay, we have defined it, guys. We have defined it previously in the previous video, right? And if we just differentiate this equation, if you just please differentiate this equation, and this equation becomes this. Now please notice that for a pure ideal gas, this dgig is going to be equal to rtd ln p, right? And you can replace it here, you can replace it here, and when we do that, we have got this change in the Gibbs free energy, or I should say the change in the molar Gibbs free energy of ith species for the ideal gas mixture, and that is going to be rtd ln xip, right? Let's move further, guys, and see this equation. Now guys, you must be remembering that we have defined fugacity, right? We have defined fugacity by replacing this p to f in the for the ideal gases, right? For the real gases, and in the same manner we are going to do that. Okay, so what we are going to do, we are going to replace this xip with the fi cap, right? Fi cap से हमने यहाँ पर इसको replace किया, guys, and you can see that, you can see here how we have done that, right? Let's move further and now integrate it. So guys, basically हम यहाँ define क्या करने जा रहे हैं, we are going to define the residual property, right? And for the residual property we have to go from the ideal gas case to the actual case, right? So वही हमने यहाँ पर किया है, guys, आप देख सकते हैं, simple equation that we have done, right? So now what is going to happen, now for the ideal gas case it will be xip only, and for the real case the xip is going to be replaced by fi cap, which we have done here. And you can see this major equation, this is actually gr, right? Gr, the g bar that is going to be g bar r, right? The partial Gibbs free energy for the residual case, right? And we know how we have defined this phi I, that is the fugacity coefficient, right? Let's move further, guys, let's move further, and to see it further, to check it further and to define more factors, let's see this g by rt term and differentiate it. Okay, let's differentiate it, simple equation है, guys, आप differentiate इसको कर सकते हो, right? So what is going to happen here, we will be getting this equation, right? When we differentiate simply this g by rt, right? Now can we replace it here, can we replace this dg and g So this dg will be replaced by vdp minus sdt, and g will be replaced by h minus ts. Okay, this is a simple thing, we know about this, right? So guys, यहाँ पर क्या हो रहा है, यहाँ पर आप देख सकते हैं we have further simplified the equation, and guys please look at this. यहाँ जो हमारी इक्वेशन बन रही है, यहाँ जो सेकेंड टर्म बन रहा है, इट इज कमिंग अप टू बी minus s dt upon rt, right? And when we differentiate this equation, because in the denominator we have t, right? So guys, हमारी इक्वेशन क्या बनने वाली है? Our equation will be this, right? And there is a same term with a positive sign in the previous equation, right? तो हम उसको cancel out कर सकते हैं, and this becomes my equation, this becomes my g by rt equation, right? और इसी इक्वेशन को अगर मैं लिखना चाहूंगा for the ideal gas, right? if my system is behaving as an ideal gas, यहाँ पर सिंपली मुझे ig का फैक्टर यूज करना है, ig का suffix यूज करना है, right? You can see that. And let's subtract the equation, right? What we have to do, we have to subtract 1 minus 2 actually, right? We have to subtract 2 from 1, right? And when we do that, we get this equation, guys. We get this equation in terms of the residual. Okay, so this is the residual Gibbs free energy, right? And this equation is applicable, with for the systems with constant composition. So you must be observing that there is no term that is there for the composition here, right? So अगर guys मल्टी component system की बात करते हैं, यहाँ पर तो component composition हमारी constant थी, यानी कि single component था basically, right? या multi भी था, but that was not varying compositions, right? So अगर multi component system होगा और varying composition भी होगी, so what we are going to do here, we have to add this term जो हमारे सॉल्यूशन थर्मोडायनेमिक्स में मेन टर्म है, गाइस आपको याद होगा, हम इसे हर जगह यूज करते हैं, राइट? द केमिकल पोटेंशियल टर्म बेसिकली, राइट? सो केमिकल पोटेंशियल टर्म हम यहाँ पर डिफाइन कर सकते हैं, सभी लोग जानते हैं जिन्होंने अभी तक की सीरीज को सुना है, अभी तक के वीडियोस को, सभी वीडियोस को देखा है, हाउ वी हैव डिफाइंड इट, राइट? So guys, what is going to happen, we can write it like this, right? So this is a simple equation, we have defined it in terms of the residual factor, right? Residual factor, this is the partial residual Gibbs free energy, right? And this becomes my equation, and here after you can see that we have defined it. Okay, we have defined it in terms of the phi as well, right? So ln phi becomes, from this equation, guys, you can see that ln phi is equal to summation of xi ln phi I cap, right? So guys, I hope ये सारे equations आपके काम आएंगे. You can just interact this equation, ठीक है? आप equations को relate कर सकते हैं आपस में, right? बहुत ही आसान रहेगा समझने के लिए आपको, right? So let's move further and see one more thing, that fugacity guys, अगर component की बात करेंगे, fugacity of a component in a mixture, please remember that, तो हम यूज करने वाले हैं ये phi I term भी, phi I cap term भी, because ये आपको बताता है fugacity coefficient which is used for the mixtures, ठीक है? mixtures में जब हम यूज करेंगे तब हम इसको यूज करने वाले हैं, राइट? और अगर आइडियल गैस मिक्सचर की बात करें गाइस, फॉर द आइडियल गैस मिक्सचर व्हाट हैपेंस, आइडियल गैस मिक्सचर के लिए phi I cap is going to 1, right? Hence my equation becomes simpler, right? So guys, I hope you like this video, आपको ये वीडियो अच्छा लगा होगा, और इसी तरह के आप और भी वीडियोस चाहते हैं, हम जल्द ही अपनी सीरीज कंप्लीट करेंगे ऑन दी सॉल्यूशन थर्मोडायनेमिक्स, एंड वी विल कम अप विद दी क्वेश्चन सीरीज अगेन, राइट? वी विल बी कमिंग अप विद आवर लाइव क्वेश्चन सीरीज अगेन in some time, right? Maybe like a day or two, after a day or two, right? I'm just preparing new questions for all of you, right? New questions will be helpful in practicing, right? So thank you all for watching the video, and stay tuned for upcoming videos. Please like the video and share it with your friends so that you and they do not miss any update. Okay, please hit the bell icon, and thank you all for watching. I'll meet you in the next video. Till then, goodbye.